All right, now that we know generally how to do Lewis structures, we're going to do a few examples from page 2 of your notes. And the first one is C3H8. So the first thing we do is figure out how many valence electrons this molecule is going to have. So carbon has 4 valence electrons, and there are 3 of them, so three carbon atoms. So for carbon, we have 4 valence electrons times 3 equals 12 electrons. Hydrogen, they have 1 valence electron each, and there are 8 of them, so that is 8 valence electrons. So add those two numbers together, that's 20 valence electrons for this molecule. We know that it's that all the hydrogens have to have just 1 bond each, so they're likely bonded to the carbon atoms. So we could put some hydrogens around a carbon atom, probably attach carbon atoms to carbon atoms. There's not really another way to do it. And then once we've drawn our structure, we have to check if we have any valence electrons left over. So if we count up the bonds, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bonds. If we have 10 bonds, each bond has 2 electrons each, so that means we have 20 valence electrons that we've used. So we have used all of the valence electrons at this point. Okay, how else could this be arranged? There aren't really other ways really to arrange these atoms. If you have some that you think of, let me know and we might be able to figure out why that wouldn't work. But we should still check to see what the formal charges are, just to kind of get some practice there. So formal charge for carbon, and this would be a good time again for you to pause and calculate this for yourself, and then restart it. So boop, restarted. We take the valence electrons of carbon, that's 4, minus the non-bonding electrons. This carbon has no non-bonding electrons, so that's 0. Plus the number of bonds, it has 4 bonds. So that is a 0 formal charge. And all of the carbons are the same in that way. All of them have 4 bonds, so all of them are going to have formal charge of 0. What about hydrogen? It has 1 valence electron. It has 0 non-bonding electrons. It has 1 bond each. So that has a formal charge of 0. Okay, let's do one that's a little bit more complicated, kind of similar to the first one that we did, CH5N. So again, we start this out by figuring out valence electrons. So carbon has 4 valence electrons times 1 equals 4. Hydrogen has 1 valence electron times 5 hydrogens equals 5. And then nitrogen has 5 valence electrons times 1 equals 5. So adding these up, we have 14 valence electrons. Okay, so how can these atoms be located with each other? Well, we know we have to have the carbon and the nitrogen bonded because they can't be connected by a hydrogen, because then that would mean that the hydrogen had too many bonds. So if we just start adding the rest of the hydrogens around, we now have 1, 2, 3, 4, 5 hydrogens added, so we're up to our H5. How many electrons have we used? We've used 2, 4, so I'm counting 2 per bond. So 2, 4, 6, 8, 10, 12. We've used 12 valence electrons. We have 14. So we should add the other 2 as a lone pair. The only thing that doesn't have a full octet is this carbon, because it has 2, 4, 6 electrons. So when we add that lone pair there, now everything has an octet. How else could this be arranged? So we'll call this structure A. What is structure B? What could that be? This might be a good time for you to take a minute and try and decide how a different structure could be come to by moving something around. So pause it, unpause when you're done. So you unpause it now. So how could that be? Well, if we have the hydrogens all on the carbon and then the nitrogen. So essentially we just flipped this hydrogen to be over there, and then we're going to change the lone pair to now being on the nitrogen. So again, which one of these is the right structure? Maybe you're at the point where you kind of know common bonding trends, and you can say, oh, well, this atom usually has this many electrons or this many bonds, so we know that this one's probably right. But again, we can do it by formal charge. So if we look at structure A, the formal charge for carbon in this structure is going to be carbon's valence electrons, so that's 4. And then we're going to subtract the non-bonding electrons, so it has 2 here, plus the number of bonds it has, 1, 2, 3. So that's 4 minus 5 equals -1. So this carbon is going to have a formal charge of -1, so I'll put that on there. The formal charge on nitrogen equals its valence electrons, so that's 5, minus 0 non-bonding electrons, plus 4, so that's going to be +1. So this is +1 there. What about this one over here? So the formal charge of oxygen, or sorry, not oxygen, carbon, equals 4 minus 0 plus 4 equals 0. So no formal charge on carbon, so that's good. What about formal charge on nitrogen? We have 5 minus non-bonding electrons, it has 2, plus 1, 2, 3 bonds equals 0. So structure B has no formal charges. Structure A has formal charges on atoms. So the better option is going to be structure B here. This is going to be a much worse Lewis structure because we want our Lewis structures to be neutral. So those are just some examples to get you started. We'll walk through the rest, which is basically page 2 and part of page 3 at the beginning of next class. And this is a really good foundation for being able to get through that pushing electrons chapter quickly. So hope you had a good time. I'll see you later.